Okay, I want to start with answers here in case you were able to work through all of them. Number one, x is, you could write it as a decimal since it terminates. You might have had 96 over 10, which that would, I guess if you reduced it down, is 48 over 5. Okay. But y is 7.2, or I guess it could be, 72 over 10, which I guess that would reduce down to 36 over 5. I would say if you get a terminating decimal, it's okay to leave it as a decimal. For number 2, now this one I am leaving as a fraction. 35 over 13 because it doesn't terminate as a decimal, so we want to leave it as a fraction. Number 3, we get x equals 4.8. Again, you could leave it as a fraction if you wanted to. The value of y here is 1, and I'm going to talk about that one a little bit more here. All right, let me go through if you need to listen to the explanation on solving. Okay, number 1 to find x. So I'm going to use that proportionality theorem where I can put into a ratio, let's see, I can put into a ratio these pieces, 8 over 2, and then x over this segment. Okay, so I can start with, now it can be 8 over 2, it can be 2 over 8. Whatever you begin with on your order, you need to make sure your second ratio corresponds. So because I started with 8, that means I have to start with x because these pieces correspond to each other. Now, this piece is not labeled, but again, I know the 12, so I'm going to call that 12 minus x. Okay. Now, I could have flipped the whole thing over. I could have 2 over 8, and then I would have to have 12 minus x over x. Now, we can reduce 8 over 2 down if we want. I'm just going to leave it and do my cross multiplying. So that means I get 2x here, and then I'm going to have to do 8 times both 12 and x. So that gives me 2x equals 12 times 8 is 96 minus 8x. Then I will want to add the 8x over. So 10x equals 96, and so there's my 9.6. Okay, so that's that. That is that first triangle proportionality theorem. Okay, the second one. Now, to get y, what I'm going to have to go back to is, I don't have this is not any sort of proportionality theorem from this section. But what I do see is that y is the base of the small triangle. 9 is the base of the big triangle. Okay, so when I set this up, I'm going to have to ratio corresponding sides. So I might resketch the pictures over here just so you can see that a little bit better. So here's my small triangle, where here is the y, this is an 8, and there's an x. And then the larger triangle, this is a 9. And then this side, I need to add the 8 and the 2 together to get 10. And then this side is 12. Now I can plug x in if I want to. But now I'm just going to ratio corresponding sides. Okay, I'm going to be able to set up a ratio where I say y over 9. I can set that equal to, let's say, 8 over 10. Okay, so I need the full side in my ratio, which makes this one just a little bit tricky. All right, so let's work over here. So I'm going to do y over 9. Go back here. I'm going to do, you can call them the base if you want to, but y over 9. And then I'm going to go back to the triangle. Since I started with y, I have to go with 8 over 10. So y over 9 is equal to 8 over 10. And then once you get your setup, it's a pretty simple equation to solve. So 10y is 72. Divide both sides by 10. There's your 7.2. Okay, So be careful on the y values, because when I don't have the sides are cut by the parallel line, but when I'm trying to get one of the two parallel lines, I have to go back to the fundamental idea behind similar triangles where I ratio the sides. Okay, number 2. So this is that last theorem, the setup. So my setup is going to be, first of all, I'm going to label, I need to know how long DC is. So I'm going to label it as 7 minus x. All right, so I'm going to start there. So my ray is breaking A in half. So I'm going to start with 7 minus x over x. So piece over the other piece. And then now I need full sides. So I started with 7 minus x, which means I should start with 8 and then over 5. Okay, and then from there we can cross multiply. So 8x equals 35 minus 5x. I went ahead and just did the distributing along the way. So add your 5x over. So 8 plus 5 is 13. So there's 13x equals 35. And then when I divide both sides by x, like I said, when I would actually divide it out. So 35 divided by 13. And when I clearly see it is not a repeating decimal, it's not a terminating decimal, so I just back up and leave it as a fraction. Okay? Okay, number 3. All right, x and y. So this one's, sorry, the picture is a little bit strange. So x goes with DE, all right, and then y goes with AD right there. Okay, so sorry if that was a little bit misleading and hard to read. So let's start with x. So I'm really just going to worry about or focus on this part right here. This is my, the theorem. If you go back a page, it's the top theorem. So I have 3 parallel lines and 2 transversals. So I'm going to be able to ratio 6 over 10, x over 8. Okay, so I can do 6, over 10 equals x over 8. Okay, and then I can cross multiply, and then when I divide by 10, there's my 4.8. Okay, now the y values, though, I'm going to have to go ahead and ratio corresponding sides of a triangle. So I just want to point out again, I have, let me switch colors here. I'm going to redraw this triangle right here. So this top triangle is y plus 5, and that part is y. Now, the other triangle that I have information on, really, I'm looking at the 2y portion. So I'm going to draw a bigger triangle. So there's the 2y in that bigger triangle. And then on this side, I'm going to add together those two, because that's making up the side. So that's y plus 5 plus 6, so that is y plus 11. So those are my corresponding sides that I'm going to be ratioing. So I'm going to start with, doesn't matter which sides I start with, but I'm going to have y plus 5 over y plus 11. Okay, so I have just ratioed those corresponding sides, and then the other set I can work with are y and 2y. Okay, let's cross multiply here. So I'm going to have 2y times y plus 5. And then the other diagonal is going to be y plus 11. So let's distribute on both sides. 2y times y is 2y squared. 2y times 5, I can do 2 times 5 and get 10, and then it will be 10y. Over here we have y times y, which is y squared, and then 11y. Now, I am probably going to factor when I see y squared and y. So let me move things over. So move y squared over. I'll maybe do it in 2 steps. You can do it in 1 if you want. So y squared plus 10y equals 11y. And then I also need this over because when I factor, I need it set to 0. So like I said, you might have moved it all in 1 step, which is fine. y squared. That's going to be a negative 1y, so I'll write negative y equals 0. Now, factoring on this is a little different because there's not 3 terms. So the only factoring I'm going to do here is factor out a greatest common factor. And they both contain at least one y, so what I can do is factor a y out of both terms. So what I would end up with is y minus 1, and you can always redistribute to check. And so then I'm still going to do those 2 equations. So the first one's just going to read y equals 0. The second one, y minus 1 equals 0. And then add 1 to both sides, I get 1. So those are my 2 solutions, 0 and 1. But we're dealing with lengths. So do both of them get to stay, or should we throw one out? So go back to your diagram. Y equals 0 doesn't work because I can't have a 0 length. So I'm going to let that be and then just circle y equals 1. And so that's my solution. Now, I want to address one thing here at the top. I often see students do this. Let me get a different color. And for geometry, you might get to the right answer, but mathematically you are missing a solution. I often see people do this. I often see them go like that. Well, those 2 y's are going to cancel, and that leaves me with 1/2. What you're going to do when you solve that is you're going to miss that solution, that second solution of y equals 0, and that's going to be a problem when you get to Algebra 2. So we are not going to be able to cancel those y's out. We're going to need to follow that through, and then at the very end we just check both solutions. Okay,